We saw the hot stage pop off. It then completed its boost back burn, put it on the course towards that splashdown zone. It successfully did that landing burn when we
operators on countdown 1. Flight directors go for launch.
Hello, everyone, and welcome to Starbase, Texas for the 11th flight test of the world's largest and most powerful reusable rocket, Starship. Today's flight marks our second reuse of a Super Heavy booster and what's expected to be the final launch of our second-generation vehicle. I'm Amanda Lee, a build reliability engineer here at SpaceX.
And I'm Jake Berkowitz, a lead propulsion engineer on our SpaceX Raptor team. Today, we're coming to you live from Star Factory, just under 2 miles away from the rocket on the pad. Right outside on the lawn, the crowd is starting to gather, and after liftoff, we expect that crowd to head back in to watch the rest of the launch with us and have a party.
And right behind us are 3 generations of Raptor engines, the third of which we're looking to debut on the next generation of Starship. And we'll talk a little bit more about that upgraded rocket later in the program.
Yeah, and if you watched Flight 10, you'll know it was a really, really good day for Starship. All objectives were met, and we got tons of great data to learn from. And today, we're looking to build on the success of that flight.
Yeah, that's right. Like in Flight 10, we're again planning to deploy Starlink simulator satellites as well as test the limits of ship's heat shield during re-entry. A controlled descent, flip maneuver, and soft splash in the Indian Ocean are also planned for ship. And hopefully, our recovery team will be able to deliver some more of those amazing views that we got back on Flight 10.
Yeah, those views are just awesome. Another crazy thing, and for those of you keeping track, today actually marks the 1-year anniversary of our historic first ever booster catch. That was Booster 12. And even though we're not attempting a catch today, every time we launch a Starship, it's a big day. All right, so everyone buckle up because maximum excitement is guaranteed.
All right.
And Dan Hewitt joins us from over near Mission Control. Dan, how are things looking for launch today?
Hey, Jake. Hey, Amanda. Hey, everybody. We are looking great. I'm Dan Hewitt with SpaceX Communications. That's right. Right behind me is our Launch Control Center here at Starbase. Flight Control team is on there. They're getting Starship and Super Heavy ready for liftoff. So as you could tell, when we look at the vehicle, prop load is underway. Things are looking good. We did shift our T0 a little bit. We're tracking to 6:23 p.m. Central Time, just a couple minutes into our window. All right, so as we noted, back in August, Flight 10, it did all the things. Did all the things we wanted it to do. Started off with Super Heavy, those 33 Raptor engines igniting, lifting off right at the top of its window at 6:30 p.m. Central Time. It was able to do a successful ascent, followed that up with hot staging, Starship's upper stage igniting those 6 Raptor engines, separating Super Heavy, making its way back down. We saw the hot stage pop off. It then completed its boost back burn, put it on the course towards that splashdown zone. It successfully did that landing burn when we intentionally disabled one of those 3 center engines. During the final phase of that, used a backup engine, entered into its final hover, shut down the engines, and then splashed down into the water. Ship, meanwhile, completed full duration ascent burn, got to its planned velocity, successfully put it on that suborbital trajectory, and then it was on to the in-space stuff. That first in-space objective was completed. 8 of those Starlink simulators were deployed. That was the first successful payload demonstration we've ever had from Starship. Each of these simulators, similar in size to the V2 Starlinks that we're going to be launching next year to add significant capacity and capability to the network. Then it was on to our second ever in-space relight of a Raptor engine. That's a key capability for when we're going to do deorbit burns on future orbital missions, and then when we're doing deep space maneuvers. Then on to the critical reentry phase, we're able to get data on the performance of that heat shield, the ship structure, push the envelope on it, using the flaps, got it down to the splashdown zone, did the landing flip, did the landing burn. Killer views from the recovery team, soft splashdown over in the Indian Ocean. We were just about 3 meters off of our target, so pretty much nailed it. It was a huge day, tons of excitement here at Starbase. Just a reminder, though, this is still the early days. I mean, we're on Flight 11 today. There's a lot more we're going to do to get the full reusability, increase our launch cadence, eventually start sending missions to the Moon and Mars. I mean, we've got thousands of launches to come. But for now, we're looking good for launch. Toss it back down to Amanda and Jake.
Awesome. Thank you, Dan. Starship is the first orbital launch vehicle engineered to be fully reusable, just like a commercial airliner. In fact, to the end, we're actually reflying a Super Heavy booster for the second time today. This booster last flew on Flight 8. So let's just start with how powerful this rocket really is. When you stack Starship up against one of the world's biggest airplanes, the 747, a single Raptor engine is actually double the thrust of all 4 airplane engines put together. So that means the Super Heavy over in the pad right now, with its 33 Raptors, is equal to the power of about 64 747s.
Yeah, that's just crazy, Amanda. The power this rocket generates is incredible. To To be specific, it's over 16.7 million pounds of thrust. Numbers almost incomprehensible, but it's just crazy. All right, to break it down, Starship is made of two parts. First is the Super Heavy booster, which is powered by 33 of those Raptor engines that run on liquid methane and liquid oxygen. And second is the Starship upper stage, powered by 6 Raptor engines. 3 are optimized for sea level performance, and 3 are for vacuum performance with that larger nozzle extension. All right, it's the Starship's second stage that will one day carry cargo, payloads, and people all the way to Mars and beyond.
The Super Heavy booster is designed to launch, separate, flip, and return to the launch site where it can be caught by the chopsticks on the launch tower. However, as previously noted, we won't be attempting one of those catches today. Starship, on the other hand, re-enters the Earth's atmosphere at the conclusion of its mission, steering itself to a vertical landing or catch. And both stages are designed to return to Earth and fly again, making this the first rocket in history that will be fully reusable.
Yeah, and we cannot forget that between the two vehicles is the hot stage ring, a structure made of steel that allows the ship's engines to ignite while still attached to the booster, enabling a faster and more efficient stage separation. Right now, that hot stage ring is single use, but in the future, it will be built in directly to the V3 booster forward end.
And finally, the infrastructure built to support Starship is referred to as Stage 0. This includes the launch pads, tank farm, and the launch towers, which hold the chopsticks that catch the Super Heavy booster and eventually will also catch the ship.
Yeah, and to get us ready for launch today, we recently conducted another static test fire, basically where we fire up the engines to mimic a launch without actually launching. You're seeing the booster on the screen right now. It's a crucial milestone to let us know we're ready to go. And then here we're seeing ship. We did this for the second time on a retrofitted mount on Pad 1. We had a full 9-second duration burn on all 6 engines.
We should also note that today's launch on Pad 1 is intended to be the last launch on this pad in this configuration. As we head into the next generation Starship flight test program, we'll be modifying Pad 1 to meet the demands of our future missions.
Yeah, and among many other things, we're installing a new orbital launch mount, a new flame trench system, and upgrading the chopsticks for future catches. So until that's complete, we'll be running operations from Pad 2, which will be coming online very soon. All right, let's go over to Hawthorne, where Tyler is ready to talk a little Starlink.
Thank you, Jake and Amanda. My name is Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Starlink is SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. So, Starship is outfitted again today with 4 Starlink terminals, powering those incredible live shots of ship in orbit, through re-entry, and then all the way down to splashdown in the Indian Ocean. Now, we've had a couple of recent milestones that are worth celebrating. Back in September, we launched Starlink for its 300th time. And this summer, we surpassed 7 million active customers with service available across 150 countries and territories. We've come a really long way since turning on service for our first paying customer in rural Idaho 5 years ago, back in October of 2020.
Maples are looking beautiful.
I'm Wendy Layer. I live in Sandpoint, Idaho, and we are the first Starlink customers.
With Starlink, we didn't have to compromise on where we live due to the lack of technology.
The minute they turned it on, we could stream a movie, we could video chat, we could play games on the internet without a lot of lag. I changed jobs earlier this year, so now I actually have the ability to work remote.
Here's my house. Program runs on the cloud. I can send anything I want out to get prices and designs.
I like to bake, so I've been able to research recipes and try new things.
Good day, go for a walk.
Good day for a walk.
We can live very rural, and yet we are connected to anybody like in the city.
And I'm happy to report that Wendy and Sean are still Starlink customers today. So in just over 5 years, we've added dedicated services for aviation, maritime, RVs and rail, and have expanded our emergency response capabilities. We've activated high-quality internet for millions of people, including those that live in some of the most remote places on Earth. Starlink is enabling rural school districts, counties, and tribal governments to offer online access to education, telemedicine, and many other critical services, in some cases for the first time ever. And yet, a third of the planet continues to go without access to reliable high-speed internet, so there's a lot more work for us to do. But Starlink was designed from the very beginning to meet these needs. And as each new version of Starlink comes online, the constellation's capacity and performance increases significantly. The larger V3 satellites that will deploy from Starship will bring gigabit connectivity to users and are designed to add 60 terabits per second of downlink capacity to the Starlink network. That's more than 20 times the capacity added with every V2 mini launch on the Falcon 9. And then on the cellular front, last month, SpaceX announced a deal that provides Starlink with exclusive spectrum for its next generation direct-to-cell satellites, which will be capable of providing broadband service to cell phones globally. Starlink is the largest 4G coverage provider on Earth. Over 7 million people across 5 continents already rely on Starlink to connect their LTE phones to data, voice, video, and messaging, where terrestrial service is unavailable. So we're excited to have the opportunity to help close those coverage gaps and ultimately eliminate mobile dead zones around the world. So yeah, there's a lot happening with Starlink, and there's a lot more to come. So let's head back to Amanda and Jake at Starbase to take us through today's flight profile.
Thank you so much, Tyler. So today's flow profile, we're looking to get our second re-entry with this iteration of ship. And prior to every launch, we work closely with the FAA and international air traffic organizations to efficiently and safely integrate launch and re-entry operations into the airspace.
And we've got a special guest here. We're live.
What's up, guys?
How's it going? Good to see you, boss.
Hi.
Hey. How's webcam?
Good. We're live right now.
What the?
Yeah. Getting ready for Flight 11. How are you feeling for it?
Good. This is the first time that I'm going to be actually outside standing and watching the rocket. Because normally I'm in mission control and stuff.
Okay. Yeah.
But now I'll be standing out in the garden there.
Okay.
So
awesome.
It's really going to be much more visceral.
Yeah. You're going to feel
Great
it.
place
It's
to
going to
watch.
be. It's going to be. It's going to be awesome. We'll be in here this time, but usually we're out there watching. Yeah.
All right. Sounds good.
Good luck.
Later.
And have fun.
Have fun.
All right, so that was an exciting cameo there. But yeah, starting with liftoff, we'll get into the flight profile here. Super Heavy will ignite 33 engines, 24 of which are flight proven today. We'll power through ascent ahead of hot stage separation, where booster will shut down all but 3 engines. Stage 2 lights its Raptor engines while still attached to Super Heavy. That is what we call hot stage separation. We'll see a directional booster flip and engine relight for boost back. And we'll be intentionally headed to a splashdown in the Gulf with a V3 style landing burn demonstration today.
Meanwhile, ship will continue with its ascent burn to a suborbital trajectory, where it will attempt to deploy 8 Starlink simulator satellites. And we're also planning to relight a single Raptor engine. Then it's time for a re-entry, where we're once again testing the limits of Starship's heat shield by intentionally removing tiles. The ship will also perform a pretty dynamic banking maneuver that mimics the path of a return to launch site for Ketch that will fly on a future mission. And if all that goes as planned, we'll conclude the test with a landing flip, burn, and soft water splashdown in the Indian Ocean. So definitely another action-packed flight profile, Dan.
This is planned to be the final launch of this version of Starship, version number 2. Right now, we're actively building multiple next-generation V3 Starship and Super Heavy vehicles in the factory, kind of right behind us, so let's take a minute and nerd out a little bit. All right. Those are going to be launching from Pad 2, which is nearing completion down here at Starbase. Both the pad and the vehicles are going to roll in really significant changes. This is building on everything we've learned from all of these flight tests to make a vehicle that we're looking to mass produce. Starting with the Starship upper stage, which is going to look pretty similar on the outside, but it's getting pretty much a complete overhaul under the hood. We're getting major design changes to its propulsion system that's going to accommodate that new version of Raptor, which puts out higher thrust. We're also getting energy storage upgrades, tons of avionics changes, a lot of things that will enable longer duration missions. One notable thing you'll start seeing on the outside are these new docking adapters, which we'll use when we bring 2 starships together for propellant transfer. That's a core capability of Starship that we're going to demonstrate next year. Bottom line, though, this is the Starship we're planning to use for all of our next major milestones, orbital missions, return to launch site and catch, reuse, propellant transfer, and then making our way to the moon and Mars. Now, Super Heavy, we've shown some of this off, some of this hardware already coming out of the factory. It has upgrades like this, a redesigned fuel transfer tube. That thing's roughly the same size as the first stage of a Falcon 9 rocket. That channels all that cryogenic fuel down to Super Heavy's 33 engines. We made it bigger. basically a rocket inside of our rocket that gives us a faster, more reliable flip and simultaneous engine startup. New booster also going to have an integrated hot stage, a lot more vent area, and it's designed to be fully reusable. Pressure from those engine plumes gets vented out, mostly offset just by the pressure in the fuel tank. That is the top of the fuel tank. And then we add a non-structural layer of steel on the top that helps take all the heating. It's mapped to where all the high heating goes. Grid fins also getting a big change, going from 4 down to 3. They're 50% larger, though, much higher strength. They're also going to get used for vehicle lift and catch. That's all made possible. There's a new catch point addition on those grid fins. We've also kind of reclocked their position on the booster. That aligns them with the catch arms. Yeah, we got it right in the middle there. All right, and then powering it all, Raptor 3. Looks radically different, just straight up radical. Tons of major changes. It's coming in higher thrust, dramatic reduction in parts, tons of control mechanisms moved inside. Our McGregor teams built some additional stands like this one, which essentially is the bottom of a super heavy booster, lets us do gimbal or steering tests. So that's been really exciting to see. We've also been getting vacuum versions of Raptor 3 into test. The first flight engines are already in production and are about to start acceptance testing for Flight 12. So a lot of exciting changes coming, and we're getting ready to mass produce everything, including one of the really key contributors to that rapid reusability, the heat shield tiles. Let's jump over to Tyler real quick in Hawthorne, who's got a really cool look at what's happening with tiles in Florida.
Thank you, Dan. Indeed, Starship's heat shield is the linchpin to full and rapid reusability. We can't launch, land, refuel, and launch again if we have to spend months refurbishing the heat shield after every launch, like they did in the Space Shuttle program. So, in a future where Starship is flying several times a day, many, many thousands of heat shield tiles will be required. So yeah, we need to get cooking on those tiles, which is exactly what's happening inside the fully automated bakery down at the Cape. In just 3 years, tile production at the bakery has surpassed the total number of tiles produced during the 30 years of the shuttle program. To go from the raw material to a finished tile, it takes about 40 hours. And today, the bakery is producing about 1,000 tiles a day. But it's set up to produce enough tiles for 10 ships per month, which is about 7,000 tiles a day, or a tile off the line every 13 seconds. So yeah, the bakery is well on its way to providing Starship with all the tiles for missions to Mars and beyond. And for today's flight, we've made a modification to the heat shield tiles. Dan, do you mind filling us in on what's being referred to as the Crunchwrap tile?
Absolutely. I always love to get to do a little show and tell. So we've got thousands of these heat shield tiles covering Starship. Now they're kind of all next to each other. There's a small gap in between all of them. You got to leave a little bit of space as that metal underneath will expand and contract. That way they don't crunch into each other and start breaking. However, that lets some of that plasma kind of seep through, and we see really high heating on the sides and then down on the metal. To help fix that, we have this, the crunch wrap that everyone has heard about. So we take essentially that's called Vulcan felt that we then wrap around. And so as these tiles are next to each other, you've got a small bit in between that's going to help offset that heating. It's just one of the ways we're continuing to iterate on this heat shield, getting towards rapid reusability. Hopefully it's going to help Starship live Moss. You know, everything is just going to get us to that end state of a fully and rapidly reusable vehicle. So pretty much the entire vehicle has those on it today. We've done this on multiple Starships previously, but this time pretty much the whole vehicle has it. So that was special for today. All right, enough heat shield tiles. Let's go quick check-in on the pad. So if you did notice, we did shift our T0 just a little bit. We're now counting down to 6:23 and 41 seconds Central Time. We shifted a little bit as we were working to finish clearing the range. We are monitoring sea and airspace, both here over the Gulf and in our splashdown location over on the Indian Ocean. We were working with the FAA, a lot of other international agencies to coordinate all of this. Good news, range is currently green. We're able to get everything out of the way that we were tracking in the Gulf. So weather status, I don't even really need to do. Not a cloud in the sky, beautiful day, no probability of violation for launch at this point. We're not currently tracking any issues on the vehicle or the pad. You can see our fill levels are getting up there. We're almost completely done with our propellant loading. We've gone through all of our checkouts so far this morning, aligning our guidance, navigation, and control system, getting the vehicles ready for prop load, the farm. Everything has gone pretty smoothly so far. We got through our go, no-go for prop load. That happens at T-minus 1 hour and 15 minutes. We've been loading fuel and locks on board the ship since about 53 minutes before launch. Booster started just about 10 minutes after that. We continue loading prop until just around 3 minutes before liftoff, and then at that point we'll be ready to go. So bottom line at the moment, we're looking real good. Again, 6:23 and 41 seconds Central Time is our target T0, so we're going to keep counting down.
Sounds like great news so far. Thank you, Dan. And we do say it repeatedly because it's important to understand, but these flight tests are all about the data. Data helps us build and fly faster until we're eventually ready to fly people and cargo at scale to Mars. That is our foundational mission and basically just the major inspiration for our work here every day.
Yeah, that's exactly right, Amanda. And our first missions to the Red Planet are just down the road, and we recently shared some exciting news. Starship cargo flights to the Martian surface for research, development, and exploratory missions begin in 2030, and we already have our first customer.
Yeah, exactly. Starship is open for business, and one of the first payloads will be provided by the Italian Space Agency. They recently signed a first-of-its-kind agreement to carry Italian experiments on the initial Starship missions that deliver customer payloads to Mars. In related news, Starship cargo flights to the surface of the Moon for research, development, and exploratory missions will start in 2028. So a ton of Starship activity to look forward to, and if you'd like to learn more about our mission to making humanity multiplanetary, go ahead and visit spacex.com/Mars. Okay, now as we get closer to launch, development continues down here at Starbase, Texas, to shape this growing city into a truly unique place to live and work. And part of being a city, particularly one surrounded by nature, is environmental stewardship. The nearby Boca Beach dunes have unfortunately been eroding at an alarming rate for some time, so SpaceX is teaming up with Cameron County and the city of Starbase to stop that erosion and hopefully preserve the beach for years to come.
Yeah, and as one of its first permanent residents and someone who's actually called Starbase home for over 3 years now, I can tell you the beach totally adds to the uniqueness and awesomeness of living here. Starbase is truly unlike any other place on Earth. You know, where else can you see the world's biggest rocket every single day?
Yeah, Starbase is definitely the place to be, and we're always looking for more people to come help build the future of spaceflight.
Yeah, particularly engineers, especially for our propulsion and mechanical system teams.
You could be working on tests just like these ones, proving out the designs of our next generation Super Heavy booster. Fun fact, we actually tested the booster to 13,400 tons of thrust, which is more than the power of 3.5 Saturn V rockets, which is just crazy. We're also looking for civil and structural engineers to help literally build the future.
Whether it's buildings like the Gigabays currently going up at both Starbase and the Cape, each is a massive vertical integration and assembly facility with over 700,000 square feet of workspace. Both sites are currently in progress, actually going vertical as we speak. Or you could be designing the Starship launch sites of the future. There's really no shortage of future to build here. So visit spacex.com/careers to see all of our openings if you're interested.
Okay, now as we head into terminal count, all eyes are on the rocket. Dan, how are we looking? Are we green?
Amanda, we are so green. Everything's still looking really good. So we've got a green range, not tracking any blockers there to launch. We're continuing to load prop on board the vehicle. We're just about to close out, so we'll close out, again, just about 3 minutes and 20 seconds before liftoff. We'll close out on ship, and then booster just about 30 seconds later, and then you end up with about 11 million pounds of liquid propellant on board those two stages. After we're fully loaded on the vehicle, the pad itself gets ready for launch. We do what's called pushbacks. We clear all that prop out of the lines in the tower and the feed system back into the tanks to get ready for launch. And then in the next couple of minutes, we're going to do our final GNC guidance, navigation, and control system alignment. We're going to arm the automatic flight safety system, and then we're going to do final kind of wiggle checks on the steering for the engines, which we might be able to catch a quick peek at as we get closer to those. If we need to hold, which we are not currently tracking a reason to, that would happen at T-minus 40 seconds. It's built into our countdown. We can pause and wait there for any final checkouts, anything that we need to hold for.
Once we pass that T-minus 40 seconds, a number of events will occur in rapid succession. The ground spin and ignition systems come up to flight pressure, and ship switches to internal power. After that, the quick disconnect arm lockout is removed in preparation for retraction shortly after T0. Now, once we pass T-minus 40 seconds, if any problems come up, we do still have the ability to recycle the count under certain conditions back to T-minus 40 seconds and hold there to assess what happened and then see if we can proceed again to liftoff.
Yep. However, once the water for the deflector system begins flowing at T-minus 10 seconds, any issue after that would be an automatic scrub for the day, as teams would need to refill the deflector's water tanks as well as the propellant storage tanks at the tank farm before making another attempt.
All right, we are coming up on 3 minutes away from launch. You can see the frost line all the way up. We've just closed out prop load onto the ship. Booster coming up shortly. Yeah, in about 10 seconds, we'll finish loading prop on the booster, and then again, we'll have about 11 million pounds of that liquid oxygen, liquid methane on board the vehicles. Not currently tracking a reason to hold at T-minus 40. It can pop up at the last moment or after we pass that gate. We can always hang out there for a couple of minutes if we need to. We do have some extra time. We're not constantly topping off the propellant in these vehicles, so we have about a 7-8 minute window where we can wait for any final issues to clear. We're not currently tracking a reason to hold there. Again, our range continues to be green as we look at sea and airspace both out over the Gulf and in our reentry zone out in the Indian Ocean. All right, 2 minutes, 15 seconds to go. A lot of things on tap for Flight 11. Planned to be the last launch of this version of Starship and Super Heavy. Once again, we're really focused on getting ship over to reentry. Once we get to that phase, we're going to dive in. There's a lot of exciting stuff that's going to be happening on our way back through and down to the ground, hopefully out in the Indian Ocean. Minute 45. Should hopefully be seeing... There's a quick wiggle check. Checking out the thrust vector control, the steering on the booster. We use those inner 13 engines. Doing their one final dance before the big show. And we'll do that one more time after we cross that T-minus 40 gate. All right, range continues to be green. Still not tracking any issues on vehicle or pad. 1 minute to go. As a reminder, we can hold at T-minus 40. We're not planning to. All right. We're through T-minus 40. Let's listen in. Flight Director Ty Huntington back in the seat. Take us through the final
Flight
seconds
Directors, go
until
for launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Go Super Heavy. Go Starship. Thanks for all the historic flights, Pad 1.
Eagles pitching downrange. Booster Raptor chamber pressure nominal.
Booster and ship nominal power and telemetry.
All right, we are about 45 seconds into flight. We're still getting the rattle here at Star Factory. We are seeing 33 out of 33 Raptor engines lit on Super Heavy as it arcs across the Gulf. Coming up next on Max Q.
Max
All right,
Q.
So at this point, we've passed through that period of maximum aerodynamic pressure. The next thing we're looking forward to is going to be hot staging. So we've got 33 out of 33 Raptors lit. Super Heavy makes its way uphill. Hot staging is going to be coming up in just a little over a minute. At that point, we're going to see all but 3 of those Raptor engines on Super Heavy shut down. Our version of MECO. Most engines cut off instead of main engine. And then after that, we're going to release the clamps that are currently holding Starship to that hot stage adapter. It's then going to ignite its 6 Raptor engines to push it away from Super Heavy and then start making its flight uphill. So in about 30 seconds, we're going to see the engines start to shut down on Super Heavy. You'll see them kind of shut off in separate banks until we've just got those 3 center engines that never stop running for this process, and then looking for 6 ship Raptors. All right. MECO coming up in about 10 seconds. See the engines throttling down.
Booster engine cut off. Ship ignition.
Stage separation.
Boost back burn startup.
All right, successful hot staging maneuver. So we've got 12 of the 13 engines lit back up on boosters, so it's doing its boost back. Real excitingly, though, we've got 6 out of 6 Raptors lit on ship there, so it's now going to continue to make its ascent into outer space. Meanwhile, this boost back is happening. We're using those 13 engines, so everything, well, 12 out of the 13, and then we go down to 3, and then we're going to shut down for the end of boost back. That's sending Super Heavy back towards its planned splashdown zone in the Gulf. Right after we finish this boost back burn, we're also going to separate the hot stage. This will be the final time that we're doing this. All right, there's the end of the boost back burn. We should be seeing the hot stage. There. So the hot stage separates. It's going to make its way down, also splash down in the Gulf. In the meantime, though, these 6 ship Raptors are going to continue firing for about 5 more minutes. Next up for the booster, though, is going to be its landing burn. There's a cool tracking shot. We dump some of the prop out on our way back in. All right, so for booster, this is one of the main things we're trying to get is going to be this landing burn. So you can see the hot stage kind of making its way towards the left side. So that's the bottom of the booster. It's about to pass right in front of where you can see some of that prop dump happening. They look like they're close together, but there's a good amount of distance between them, and the hot stage will go down and splash down in the Gulf while the booster comes back for its landing burn.
Starship is on nominal trajectory.
All right. Looking good on our trajectory, looking good on everything. Jake and Amanda, you guys with me down there?
Yeah, definitely. The crowd is gathering over here in the office. You can definitely feel the energy in here. Great to see that booster is making its way down to the splashdown zone in the Gulf.
Yeah, the shaking down here was absolutely nuts. The windows are still there, still intact. So that was pretty awesome. But yeah, booster's coming down. We're at about 30 kilometers. All right, yeah, and as we approach that landing, just like tower catches, we will be doing a 13-engine landing burn to slow down. This time it will be in a V3 configuration. And as we're starting to get into the denser part of the atmosphere, the booster is using 4 hypersonic grid fins to guide itself through atmospheric entry towards its landing site.
And we're just about 20 seconds away. From landing burn start, where we'll first ignite the center 13 engines, then bring that down to 5 to slow down the booster for landing. And finally, that will come down to 3, and we'll cut all of them off while we're still about 200 meters in the air. So booster is going to see a bit of a harder thing.
Booster landing, we'll start it. Booster landing, we're in shutdown.
And there we heard it. Booster landing burn shutdown. We saw a 13 to 5 to 3 V3 demonstration, and into the water we go. Wow, that was absolutely awesome. If you can even hear us right now, congrats to the whole SpaceX team. So far, so good for today. That was incredible.
All right, great stuff, guys. I'm jealous of the crowd. All right, back to ship. Ship's still making its way. We've got a little under 2 minutes left in this ascent burn, so we've got all 6 Raptor engines still firing. So the next major milestone we're going to be looking for is SECO. That's our second stage engine cutoff. That's should be coming right at about 8 minutes and 58 seconds into flight, so we've got about 1:20 still to go. Really cool to see Booster go through that landing burn. That was one of our really key demonstrations we wanted to try and do today. That's mimicking what we're going to be hopefully doing. Oh, we just got our sonic boom, sounds like, from the booster coming back. All right, less than a minute to go. So we are going to see the 3 RVACs, the vacuum optimized engines, shut down first, and then we'll shut down those 3 center engines. So we should be a little under a minute until SECO. Just a reminder, this is putting us into a suborbital trajectory, so we're intentionally just going slow enough that we're not going to achieve full orbit. This puts us on a course where those engines shut off, and no matter what, we're coming back.
Starship is in terminal guidance.
In the Indian Ocean. All right, terminal guidance. So we should start seeing the shutdowns come up in just a couple seconds. Less than 30 seconds to go in this ship ascent burn. All right, RVACs have shut off. 3 more to go.
Ship engine cutoff.
All right, all ship Raptors have shut down.
Nominal orbit insertion.
You just heard nominal orbital insertion, so we are on the path that we wanted to be. So we've got a ship back in space, a whole lot planned for it, lots more still to come. Great seeing Super Heavy make its way to the water, but I'm excited to see what ship can do in space. How's everybody doing down there?
Yeah, if you could hear the crowd behind us this whole time, people are definitely happy with how the day's been panning out so far. Definitely exciting to see Starship safely in space, and super pumped to see all the team's hard work in action here today.
Yeah, and we guaranteed it at the start of the show, but it has been an awesome day so far. It's crazy. All this has happened in just 10 minutes. All the objectives were met on the booster, including that V3 style landing burn. So now all eyes are on the ship as we get ready for our in-space objectives. But we've got a few minutes until that next milestone, so sit tight, enjoy the views, enjoy the space jams. We'll be back at T plus 16 minutes for payload deploy.
right, welcome back, everybody. If you're just now joining us, where the heck were you? But we are getting ready for payload deploy. That's going to start once we get the payload door open. That should be happening, or at least starting, within the next minute or so. It's been a really cool flight so far. Quick look inside the payload. We've got 8 Starlink simulators getting ready to make their way into outer space. But great flight so far. Booster able to make it all the way to its splashdown and landing burn experiment, so that was really exciting to see. We got ship on orbit, nominal orbital insertion, so right on the money with its trajectory. And now we're ready to start tackling a couple of in-space objectives. So next up, we are currently venting down the nose cone, essentially the payload area of Starship, as we get ready to open up this payload door. We were able to do this successfully for the very first time on our last flight, on Flight 10. Oop. Hal got ahead of me. Looks like he's opening up the payload door already. All right, looks like we got the door open. All right, so payload door is open. Next up, going to be to start deploying these Starlink simulators. They are roughly the same size as the V2 Starlink satellites that Starship's going to be carrying. That's going to add some pretty crazy capacity. We'll run through the numbers in a little bit. We were able to do this for the very first time ever on our last flight, and so this will be another test. We made a couple of tweaks to the rails for deploying this based off of what we saw last time, but excited to see these get out the door. Our next iteration of Starship's also going to have kind of a more powerful PEZ. It's going to deploy these at a little bit faster speed, but looking to see our next demonstration of this hopefully in the next couple of seconds. We should start seeing them move out the door. I mean, that view on your left, so you're basically, that would be if you were sitting at the very top of the nose cone looking down. So there's kind of a short stack. There's 4 on either side, so 8 total. When we start flying Starlinks, for their actual deploy missions, we're going to be carrying stacks of about 60. So much larger stack once we start flying these operationally, but still doing a little bit of a short just for this payload deployed today.
Looks like we got a little bit of movement there, Dan.
Coax it out. Get it moving, Jake.
There we go. All right, first one going out. All right, first one's deployed. Getting ready for the second one here. We do a little reset back to the center position.
Yeah, it takes about a minute for each one.
Looks real smooth too. They made a couple of tweaks to those rails. If you watched the last ones, it had a couple of bumps on the way out, but moving out super clean this time.
Yeah, and as noted earlier in the show, but definitely worth repeating, Starship will deploy Starlink's more advanced V2 satellites, adding 60 terabits per second of capacity to the network per launch. So that's 20 times more than each Falcon 9 launch does today. Just incredible.
Yeah, and anybody that's been following Starship, you know Starlink's kind of the MVP for these flight tests, where it's not only giving us the views we're seeing right now, but also just real-time data through every phase of flight. So We've got a couple dozen cameras on Starship. We've also got a bunch of cameras spread across the globe, including out in the Indian Ocean, where we've got our fun buoys floating. There goes another one. And I mean, we're using Starlink to bring all of this together. It's our drone shots you see here from our great team down here at Starbase, all connected. So Starlink not only giving us cool views off the planet, but also on the planet, help bring everybody along for all these Starship flights. I think that's number 4. Somebody check my math. Okay, we've got 4 Starlink terminals on the outside of Starship. He uses that to talk to the constellation, and through that we actually get about 120 megabits of bandwidth for our downlink. That's our real-time HD video, all of our telemetry, so it's not just kind of giving us these cool views inside, but it's giving all that engineering data in real time, including re-entry when normally a plasma layer builds up and blocks you out. Starlink, powerful enough of a frequency that we're able to kind of punch through that and still get that live view. All right, next one out the door. There we go.
All right, yeah, Starlink is the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people around the world, many of who have never had connectivity before. Oh. Right. Today, Starlink serves more than 150 countries, territories, and other markets, with over 7 million active customers and counting. To meet the global growing demand for high-speed internet, SpaceX expanded its factory over in Bastrop, Texas, which is just outside of Austin, and also introduced Starlink Mini, as well as an upgraded version of the Starlink Standard Kit.
Yeah, and one thing to note about this satellite deploy is that they will be following the same suborbital trajectory of the ship. So these dummy sats will not be going in orbit. We do expect them to burn up on re-entry.
All right, couple more to go. I promise one of these days we'll deploy in daylight. But we're basically trading deploy in the dark so we get those re-entry views for the daytime. All right, I think we got one more to go.
All right, now with payload deploy complete, Starship will now close its payload door and continue to coast around Earth to the Indian Ocean. We still have a ton of major events to come today, including Raptor Relight at about T plus 37 minutes. That will be followed by atmospheric reentry and splashdown. So with that, we're going to go on another quick coast.
Yeah, if you can hear us.
All right, with that payload door closed, we're going to sit tight, enjoy the views, and enjoy the space jams. Again, we'll be back in just a few minutes for Raptor Relight, and then head back for reentry. Welcome back, everyone. If you're just joining us, you did miss some exciting stuff because Starship successfully deployed its second ever payload, 8 Starlink simulator satellites. And now we're expecting the relight of a single sea-level Raptor engine in space coming up here just after T plus 37 minutes. So about a minute left to go.
Yep, just a little while. I think we're tracking to 37 in around 49 seconds or so. So we should be just about a minute and a half where, again, as Amanda just said, we're going to relight one of those center engines. This will be the third time that we've tried this. We did it successfully back on Flight 10, and then we did it for the very first time back on Flight 6. This is not a deorbit burn. This is demonstrating essentially all of the systems you would need to do a deorbit burn. So that's obviously your Raptor engine, and then also your header tanks, your smaller tanks in the nose cone, where we have liquid oxygen, liquid methane in a smaller, more easily pressurized container, which we can use for on-orbit burns. And we're also going to tap into those when we do our landing burn. So this will be a critical capability. Once we go to full orbital missions, you'll have to do a deorbit burn to break out of orbit, send it back down to Earth. But in this instance, we're already on our way back down towards Earth. So this is just going to demonstrate the capability of turning one of these engines on. We should be coming up in just about 20 seconds or so, looking for one of those Raptor engines to turn back on. They've been off since we completed that successful ascent burn almost 30 minutes ago. Here we go.
Oh, Raptor ignition. And shut down.
All right, there was that Raptor relight. Looks like engine 3 full duration. As Dan mentioned, that's the third attempt, and we just did it 3 times in a row. So congrats to the team, the ship team, Raptor team. And then there we heard nominal second orbital insertion. All right, so congrats everyone on the milestone. That was awesome to see. We're 3 for 3. We're going to take another break, and we'll be back for re-entry at about T plus 45 minutes. We'll see you soon.
Starship is slewing for entry.
Looking good. We are counting down. We moved into our window a little bit, but we are looking good right now at this moment. Behind me, you see the flight control team. They're on console looking at the rocket, the pad, the range, the weather, everything as we count down to liftoff. We're going to be getting into prop load in just a couple of minutes, and we are counting down to a liftoff at 6:30 We are counting down. We moved into our window a little bit, but we are looking good right now at this moment. We haven't had a blue sky all day. You see the flight control team nothing but that. Looking at the rocket, the pad, the range, level winds a little bit earlier. That's why we moved into our launch window. But the great news is we are looking go for launch. Also, we're monitoring the range, so air and sea space out in the Gulf and also in the Indian Ocean on the other side of the world, not tracking any issues there. Now, today's countdown functionally going to look pretty similar to most people. There's a couple of differences in timing for some of those major milestones, like when we start loading propellant, when the diverter turns on and the water's flowing, when the engines start up, but otherwise, other than that, all of the hardware brand new. New booster, new ship, new engines, new pad. Let's nerd out. Let's dive right into it. So there it is on the pad. Say hello to Starship version 3. As Kate noted, some of the outside might look familiar, but we've made extensive upgrades across every single system. Start with the big picture because Starship still very, very big. Just over 407 feet tall, fully stacked, a little bit taller than version 2. With that extra stretch, we can carry even more propellant, but big rocket. The bottom half very top, we've changed from a one-time use hot stage adapter that used to pop off to one that's fully integrated for reusability. And Starship's Raptors are actually going to be igniting directly on top of the booster's fuel tank. The fuel tank pressure itself and then a non-structural layer of steel, it's what's protecting the top of that booster when we do hot stage separation. Moving down a little bit, we went from 4 grid fins to 3. We made them 50% bigger and higher strength. Just a reminder, that's what booster is using to kind of steer itself as it's flying back for a catch. We're also now going to use those grid fins for lift and catch itself. We zoom in a little bit and you can see new catch points now on those grid fin structures. Moving inside the rocket, we redesigned the fuel transfer tube. This is the really big tube inside the rocket that's moving all of that liquid methane down to the Super Heavy's 33 Raptor engines. It's going to help us flip faster, and we can now start up all of the engines simultaneously. This thing is big. It's about the size of a Falcon 9 first stage, which gives us the fun realization that we kind of put a rocket inside of our rocket. The very bottom of the booster looks very different. You've got those new Raptor 3 engines that enabled us to delete the bulky heat shields, the engine shrouds that we had on the previous generation. And then all of the propulsion, avionics hardware for those engines are super tightly integrated now and protected by much slimmer shielding. Move on up, second stage. This version of Starship is designed to carry massive orbital payloads. We're talking up to 100 metric tons to Earth orbit, the Moon, and Mars. The biggest changes are pretty much all under the hood. We gave the propulsion system a clean sheet redesign, increased the propellant tank volume, and improved our reaction control system, our steering while we're on orbit. When we X-ray inside, the PEZ dispenser is now supercharged, a little bit of turbo, and that's going to allow us to increase the deploy speed for each of those satellites. Today, we're actually flying the heaviest payload we've ever carried on Starship, but eventually we're going to launch with up to 60 of those Starlink V3 satellites. Just below that, just below the payload bay and also down on the aft part of the ship, we've added new docking ports. That's going to enable us to link up in orbit between two starships, do propellant transfer. We also modified that main connection point where we load propellants into the vehicle for those future prop transfer missions. So a lot of upgrades tip to tail on the rocket, but powering everything, the Raptor 3. There they are, ripping in real time. These engines manufactured in Hawthorne, California, tested at our site up in McGregor. We redesigned their entire ignition system. We bumped up the thrust, so putting out more force, went from 230 to 250 tons force on those sea-level engines, 258 all the way up to 275 on the vacuum-optimized ones. When you look at all of the generations of Raptor lined up. All of those fiddly bits, the sensors, feed lines, controllers, everything that you were used to seeing around Raptor 1 and 2, a lot of those have either been deleted, best part is no port, or they're internally integrated and protected inside of the engine itself. That'll let us dramatically cut down on the weight of the engine, make it easier to manufacture because we are going to be mass producing these things. Now, we make these Raptors in Hawthorne. There's our Hawthorne manufacturing team getting ready to see their engines fly in space for the very first time. Huge shout out to you guys. You're all wizards. Appreciate you getting us some vehicles on the pad today. But incredible amount of effort. World's best engineering team works here at SpaceX. Get this rocket to that pad ready to launch. And we've been trying to follow more of it and document some of it. And if you haven't seen it, check out our new docu-series, Starship.
We really, built this rocket from scratch, but we've also built the pad from scratch, so it's all kinds of new systems. This will be the first time that we bring together the pad and vehicle pieces to make sure that they all work.
Static fire vehicle is in pre-pad clear, about to get to our static fire pad clear op state.
We run 60 seconds on ship because you get to see how the vehicle thermals all shake out and just general vehicle performance.
That if you can make it through that you are in a reasonable position to go fly.
Start up.
Throttle up.
Plus 10.
The journey of SpaceX is a journey to give humans access to the solar system and beyond, which is really the goal for Starship.
Plus 20.
The impact that this rocket is going to have on the world, I don't think most people can really comprehend the change it's going to have.
Plus 30.
This is such a wild ride. The highs are high, the lows are low as we really work to get to ultimately launching people, which is going to be amazing.
Plus 40.
It is not impossible just because it's far beyond what has been done before. We've proved that time and time again.
Plus 50. Full duration.
Oh man, like Dan said, we've got the world's best engineering team, and I love this docu-series because it's allowing us to get a peek behind the curtains.
Yeah, the full thing is 25 minutes long, and I think I've watched it 4 or 5 times already. That's how good it is.
Same.
But yeah, so just as the team has been working hard on a brand new rocket, we've also redesigned the ground systems. The brand new Pad 2, that you can see on your screen here, is making its big debut today.
We took everything we learned from operating on Pad 1 to create this totally new launch pad. Pad 2 is optimized for full and rapid reusability. We've upgraded our propellant farm with much more storage and more pumps to enable super fast filling for launch and relaunch. On the tower, we changed to shorter chopsticks, which enable even faster motion to better track vehicles flying in for catch.
Yeah, we also changed the actuators driving those chopsticks from hydraulics to 100% electromechanical, increasing their speed, redundancy, and reliability. On the ground, the launch mount was completely redesigned, and if I had to describe it in one word, I'd say it's robust. With the extensive concrete and steel cladding, it almost feels like you're looking at a battleship, not a launch pad. But it's also smarter. We've separated the fuel and ox systems into different compartments and repositioned the booster quick disconnects to be out of the vehicle's plume during liftoff.
Yeah, and perhaps the most obvious change, we've now got a bi-directional flame diverter. We said goodbye to the pancake, and a new top deck flame deflector to eliminate metal wearing down, which will help us get to zero refurbishment between launches. In fact, that new flame trench and the new chopsticks are featured here on our new Pad 2 launch shirts. This launch pad is built for maximum safety and fast turnaround because making life multiplanetary will require launching a lot of Starships. And as the countdown continues, let's change gears for a moment and head over to Tyler Lionquist in Hawthorne to talk about Starlink. How's it going over there, Tyler?
Hey, Kate, and thank you. We're back in Hawthorne, and we have a crowd forming outside of Mission Control ready to see some Starships fly today. And like Jake mentioned earlier, on today's flight, we're deploying 20 Starlink simulators, plus 2 modified Starlink satellites, which our team internally refers to as Dodger Dogs, because we stretch that V2 mini satellite propellant tank so that it sticks out from both ends of the satellite. You can see it right there. It is just missing some mustard and onions. So the Dodger Dog serves as a tech demo between the V2 and the V3 Starlink satellites, and will act as a platform for testing those V3 components. So the larger V3 satellites aim to greatly expand the network's capacity, while V3 hardware is designed to support faster Wi-Fi and improved broadband speeds to customers while providing a significant capacity upgrade from the V2 Mini. And in addition to delivering future V3 satellites to the Starlink network, we believe Starship will enable us to launch our AI satellites. As you may have seen during the TerraFab event in Austin a few months ago, Elon laid out the path to revolutionize cloud computing and AI infrastructure, leveraging the unlimited power of the sun, targeting 100 gigawatts to 1 terawatt of AI computing power annually. And from there, we're looking at connectivity beyond our planet too. Building on the technologies used to connect people on Earth, the Starlink team is exploring using Starlink to enable high bandwidth connectivity around the moon. With a constellation of satellites designed to connect to user terminals on the lunar surface, we could relay data back to our Starlink constellation in Earth orbit. So traditionally, deep space comms have relied on radio frequency transmission. This new design would use lasers to relay data back to Earth, which can massively increase the bandwidth available to future lunar missions. We currently have thousands of lasers operating in our Starlink constellation around Earth. Deploying that technology around the moon could connect it with hundreds of terabits of capacity. Together, this could provide the connectivity backbone between the Earth and the moon and enable gigabit connectivity anywhere on the lunar surface, providing data for rovers, habitats, and astronauts, and hopefully some incredible views for us back on Earth too. So all of that adds up to a lot of satellites, but the good news is that there's still plenty of space in space. But that said, the Starlink team takes space safety extremely seriously, and we work hard to encourage best practices across the entire industry so space stays open for as many people as possible.
There are tens of thousands of known space debris in low Earth orbit right now. All of that debris comes from man-made activities.
A lot of people talk about space being really congested, and they show this dust cloud around the Earth of all these points, and it looks like space is super, super crowded. I think if you take all the spacecraft that are in orbit, it's equivalent to about 3 aircraft flying over California at one time. So space is so much bigger, so many dimensions that are much beyond what we can comprehend. But even though it's big, there still is a potential that these satellites could collide and could hit each other if we don't proactively share information.
The orbit of objects follow Kepler's laws of motion, explained by Newton's laws of gravitation. So they orbit the Earth in very predictable trajectories as long as another force doesn't act on them. So you can reasonably fit millions of satellites into an orbital shell with that math. Obviously, to make that happen, you have to have really tight coordination between all those satellites, and everything has to work really well together. Starlink satellites make something like 1,000 collision avoidance maneuvers on a daily basis. We predict that a close approach will occur between another satellite or a piece of space debris. We use the thruster of the satellite to make a maneuver and keep away from the trajectory of that object and reduce the probability of collision to effectively zero. Because most of the actual collision risk comes from the surface area of the solar panels, we lower the solar panels to reduce the cross-section in the plane of the close approach to further reduce risk. On Starlink, I'm also excited to talk about a program we call Stargaze. Cameras on the satellites looking up into space, measuring the star field. You can imagine 10,000 satellites staring up into space and detecting all the objects in low Earth orbit. You effectively almost have a real-time view of what's happening in the low Earth orbit environment. So we began detecting objects and fitting orbits to those objects, and currently we're tracking about 50% of the objects with perigees below 600 kilometers. This project has opened our eyes a bit to the activities that are occurring in space that are not being published. So we have many examples in Starlink satellite footage where an object came within tens of meters of a Starlink satellite, yet this was not predicted. This is extremely concerning because this type of incident could have resulted in a collision.
Last year, we flew 165 missions to space. As an industry leader, we would like to create a community where all industry providers share data back and forth. They tell us where their spacecraft are. They track their spacecraft as soon as they're deployed. They make them available to others so we know where everyone is. You know, there's some thought that if I keep my satellite position confidential and I don't share that with anyone, no one will know where my satellite is. Well, I think that's really fictitious. So we at SpaceX, we've taken the opposite approach. We've published all our data, we put all our ephemeris data out, we show where our satellites are, we show where we're maneuvering, and I think we're now showing the industry that there is no competitive advantage by not sharing your data. We're demonstrating to the outside world what good practices are. We as an industry have a tremendous obligation at this time, at this formative state, to actually communicate with each other, share best practices, and be good stewards amongst each other. It'll make us better as an industry. It'll give us an industry of the future that will continue to grow, continue to innovate, and help every company to grow and generate revenue.
To maintain safety in low Earth orbit, it's incredibly important that we work together as satellite operators and are very transparent in the activities that we are conducting. I think that an irresponsible satellite operator is one who either doesn't know where their spacecraft is or where it's going to go, or isn't broadcasting that to the world. Space is big, but operators are not always predictable. We want to enable other missions, the Moon and Mars and interplanetary exploration. So ensuring that activities like that can persist for the duration of humanity is incredibly important. You know, fundamentally, I think the message to operators is to be transparent about what you're doing in space, you know, transparent about where your satellite is and where it's going, and make sure you have the tools to ensure that that information is accurate all the time.
Starlink's future is bright and helping ensure space safety for all operators along the way. Now let's take a look into the flight profile for today's test. As we've mentioned a few times already, there are numerous redesigns making their debut today across the entire launch vehicle. In light of this, we want to keep our learning focused on all that new hardware and software, so we're running a flight profile similar to our last 2 Starship flights in order to minimize new variables.
Yeah, and we'll start with liftoff, where Super Heavy ignites 33 brand new Raptor 3 engines. We power through ascent ahead of hot stage separation. Booster shuts down all but 5 sustainer engines. Stage 2 lights its Raptor engines while still attached to Super Heavy. We get to see stage separation debuting the integrated hot stage. Directional booster flip, engine relight, and boost back using 33 engines. And after coasting for a few minutes, the booster today will target a landing burn and soft splashdown a few miles off the coast from Starbase.
Yeah, Ship does a bunch of fun things like deploying 20 Starlink simulator satellites, 2 of them Dodger Dogs as we affectionately call them, single engine Raptor relight, and then re-entry. Everybody's favorite part, lots of fun Technicolor colors that will be brought to us by Starlink. And if all of that goes as planned, we will finish the test with a flip, a landing burn, and a soft splashdown in the Indian Ocean. And actually, in just a few moments, thanks to Starlink, we'll be going live to the Indian Ocean and chatting with the ship recovery team stationed out there.
I'm so excited for that. That's going to be awesome.
So cool.
But sit tight, 'cause first we're going to go to Dan for a quick status check.
Yeah, thanks, guys. Everything's still looking good. We are not tracking any issues technically on the vehicle or on the pad. Range status continues to be good, both the range out here in the Gulf and out in the Indian Ocean. As you can see, we have started our propellant load. That happened at about 36 minutes before T0. We're loading about 20% faster on Pad 2 than we did on Pad 1. Our flight director, Ty Huntington's back in the chair again. He was there for Starship's first flight test and 11 back for V3. He did that final go, no go at about T-minus 1 hour. We do start loading on ship first. That happened at about T-minus 37. Booster follows about 1 minute later, starting with its liquid oxygen and then its liquid methane. And then ship fuel is the last one to kick off at about T-minus 35. We're going to continue loading all of this propellant on board until about 3 minutes right before launch. 3 minutes 20 on ship, 2 minutes 50 on the booster. So we go pretty much right down to the wire. But as of this moment, still looking good. T0 set for 6:30 p.m. Central Time. Continuing to load prop, continuing to count down. All right. If you've been following along with these launches, you know we've been sending these suborbital and they splash down in the Indian Ocean. How the heck do we see some of that? Well, we have our recovery team, our Starship recovery team, and one of their primary jobs is to get those reentry views and a whole lot more. We're going to take them now. We're joining them out in the Indian Ocean. We've got Suren Sinai standing by, taking a moment from the recovery ops. He might be frozen. Let me know if you can hear me, Suren. How's everything looking out there in the ocean?
Dan, I can hear you loud and clear. We're sitting in about 8-foot waves, but it's looking like a clear day, ready for a ship to come on through.
All right, man. How many of these have you done? And like, walk us through. What's the recovery team's primary job out there?
I've done 6 and now 7 of these missions, and with every mission, we've seen it evolve, and but our primary goal has always been to clear the range. So just like we do over in the Gulf, the same kind of happens here. We send 1 to 2 boats out and we make sure there's nothing in the area so that the rocket is clear to land. And then once we can guarantee that and have the rocket leave the pad, then we can proceed to imagery collection. So we have
All right, we'll see if we can get him back, but they're out there in the Indian Ocean. I think everyone's familiar. They've got the buoy cams. They've got the drones that are going to be going up, so we're going to be cutting back to them live once they get. They've been doing some practice stuff. We've been able to shoot some of this. So there you can see Suren getting those buoy boats. So they're basically out there. They're deploying these boats in the splashdown zone. If you get a live view from one of these boats, that tells you that we're pretty much nailing our target on that. And then Suren and a couple of our other recovery folks out there are going to be flying drones to hopefully get that imagery of Starship coming back. It's super critical for us to see just how that heat shield performed after reentry, and just having them out there remote, just in the middle of nowhere, plays just a really critical role in just rapid iteration on Starship and its heat shield. So looking forward to hopefully seeing some views from them a little bit later. But for now, let's head back down to Kate and Jake for the latest progress at Cape Canaveral in Florida.
Thanks, Dan. Now, if we want to get to the moon and then Mars as fast as possible, there's really only one answer: launch a lot more rockets.
Yeah, to do that, we're going to need a few more launch pads and support buildings, which is exactly what we're working on over in Florida. So originally built for Apollo and then the Space Shuttle, Launch Complex 39A has flown 126 Falcon missions since SpaceX reactivated the pad in 2017.
Yeah, it's crazy that it's that many. Fun fact, I actually hosted the live webcast for our very first launch at Pad 39A, and it was so exciting to see that come back to life. It's also exciting to see how today, almost 10 years later, the ongoing construction and development that will bring a second launch tower to Launch Complex 39A. You can see it ongoing there on your screen. It's designed to expand our capabilities to support Starship launches in the future, while also continuing to support Falcon Heavy missions from the original Apollo Shuttle Falcon launch tower.
Yeah, and we're also building a Starship launch pad at Slick 37. And to support the uptick in future launches, there's Gigabay, a giant assembly and maintenance facility designed to prep Starships ahead of Florida launches. And when complete, this huge structure aims to hold 24 work cells in over 800,000 square feet of workspace. That's 24 rockets under one roof. That's absolutely crazy.
Going to be so many.
Yeah. So SpaceX's future in Florida is quickly taking shape with our very first launches on the horizon.
Yes, a horizon that aims for regular trips to the moon. Now, staying with the lunar conversation, we're going to head back up to Dan, who has Starship Vice President of Engineering, Bill Riley, our favorite webcast visitor, to talk about the moon.
That's right, Kate. Yeah, crashing the webcast again. Bill Riley, VP of Starship Engineering. Thanks for coming, Bill. We wanted like a couple of minutes to geek out about the moon. Like Artemis 2 just flew humans around the moon for the first time in like 50 years, more than 50 years. I personally was wildly caught up in it. I don't know how you felt about the whole thing.
Yeah, I found it really inspirational. I think part of being a spacefaring civilization is being out there exploring, and I thought Artemis 2 got us back to the moon and back exploring and being out farther than we had been before.
It's always wild when you see space stuff kind of break through into the mainstream, and like it felt like that really did it. And I mean, that's going to continue happening. We're looking at a higher cadence of missions in Artemis, and Starship's obviously going to play a pretty big role in the entire Artemis program. But like, what's kind of next on the horizon?
I think what's exciting about Artemis 3 is you'll see the landers introduced now. So maybe we're talking to NASA about doing an Earth orbit rendezvous where the Starship-based lander could be in proximity to Orion or even more. I think that's really the next step. Prove out those landers close to home in Earth orbit, and then looking ahead, going to the moon.
And we're debuting V3 now, and just some of the stuff that's now on this version of Starship is going to directly enable some of that, or it's planned to, correct?
That's right. So V3 is exciting because it really introduces it's designed to introduce all these fundamental foundational features that allow us to go out past the Earth. So for example, there's many features, but some that are visible are the docking adapters below the PEZ door that you'll notice on the as-built ship. And then as we look out past V3, there's other configurations of Starship. There is a tanker that takes the propellant to dock with the lander that will land on the moon. And think of the on-orbit propellant transfer as sort of like the gas station in the sky. And then that gas station will be what we call the depot.
And then the plan now, and the plan's been, but it's really emphasized now, we're not just going for flags and footprints, we're talking permanent infrastructure on the moon, right?
That's right. We have to build up to that capacity. So the first landers will be, a new set of boot prints to kind of start a new generation of explorers. Then we'll build into cargo landers like you see here, maybe bringing down a rover to the surface. Some infrastructure might even be staying inside the landers. And then as we look to an even brighter future, having a permanent presence in a moon base.
Yeah, I'm ready for the moon base. I need to go to the moon. That's definitely in my. It sounds like a hell of a week-long vacation or one heck of a trip. But and I mean, this is the next step on making life multiplanetary, right?
Absolutely. It's literally the next planetary body we need to get to. So.
All right. Well, thank you so much, Bill. I'm going to let you jump back in there as we get ready to launch this rocket. Thanks for nerding out on the moon with me for a couple of minutes. But we're not done. We got a little bit of more cool news. Stick around. Last year, the From 2 crew made history. They were the first astronauts ever to explore Earth's polar regions from space in Dragon. I got to catch up with that mission commander from that, Chun Wang. He was visiting one of the most remote places on the planet, and he had some exciting news. Awesome to talk to you. Start me off. Where the heck are you right now?
Thank you for joining me to Fui Island, and this isolated island in the South Atlantic. It's arguably the most remote island in the world.
It looks super isolated. You're only there with a couple of people. Kind of feels like a space mission to me. So let's just jump right in. You are going to be on the first interplanetary mission on a Starship.
So it's going to be a flyby mission of Mars. So a lot of people are talking about how Mars will be like. We're going to fly to Mars, we're going to land on Mars, we're going to build city on Mars. But let's get it started with a flyby.
Doing a flyby of Mars, that's a heck of a trip, but you're kind of built for this kind of mission, right? Because if you're not landing on the surface, you're spending a long time going out there, you're going to fly by it. It's going to be like just an insane couple of hours, and then it's a big trip back home. How are you kind of built to handle this kind of a journey?
This actually my style of spiral. I can stare at the map view on airplane all the way from takeoff to landing. So I think I'm enjoying the trip.
So it's not just the Mars flight, you're also going to be taking a trip around the moon, right? So kind of do that step before heading all the way out to Mars.
Yes, because even though it's just a flyby, it will try a lot of things that never been attempted before.
How do you kind of see these types of missions in kind of the grand scheme of everything?
It will light the fire. It will ignite imagination, and it will build the momentum. After we come back from Mars, you'll have an opportunity to take some real photos of Mars. Mars will no longer become a distant place. It will become reality.
Well, Chun, thanks for calling in from, the other side of the planet. Super cool location, super cool to talk to you. And I mean, exciting. You're going to get on Starship, you're going to go around the moon and then do the first flyby of Mars. It's insanely exciting stuff.
Yeah, looking forward to that.
Oh, man. Fireworks indeed. Just incredible to be one of the first humans to become an interplanetary traveler while also joining Starship's first mission to fly past the moon.
Yeah, Chun is certainly a one-of-a-kind explorer. And it's even more exciting to know everyone can join a future Starship mission.
Yeah. If what you just heard excites you, challenges you, inspires you, we'd like to hear from you. Come join our team. Be one of the people walking past us out to the lawn to watch the world's best rocket launch. Help shape the literal future of humanity. Now, we need the best and the brightest, and we need you right now.
Yeah, and we have tons of openings all across the company where we're looking for talented engineers and technicians at all of our sites, including McGregor, Texas, where we test every single one of these Raptor V3 engines behind us. Bastrop, Texas, where we build and assemble Starlink user terminals.
We also need help up in Redmond, Washington. That's Starlink's global headquarters, where, among other things, we manufacture Starlink satellites. If you like the fall weather, that might be the place for you. And as you've seen throughout today's show, there is a tremendous amount of activity happening right here at Starbase, Texas. Here and everywhere, it's all part of the incredible opportunity that we have to build the future of humanity.
Yeah, so if you're interested, visit spacex.com/careers to see these and all of our other openings.
Now, I can tell you that the crowd is certainly starting to grow. Behind us, you see the launch pad there for yourself. Once again, this is the first flight test of Starship version 3. This will be the first time that we are debuting this booster, this ship, the launch pad that you see there. And you can see people walking over my shoulder here as our colleagues are moving in masses to go watch this liftoff in just over 7.5 minutes from now. It's pretty exciting stuff.
It's pretty exciting, and as a reminder, we're only 1.5 miles away here. So we are very close, about as close as you can be, and we're definitely expecting to feel it.
Sorry to interrupt you, Jake. Hi. Do we have a mic? Hello, for those of you that might not know.
How are you guys?
Welcome, Nikki. It's so nice to have you here.
It's a pleasure to be here.
Oh my gosh. What do you think the Barbs are going to say when they see you here at Starbase?
They better say all good things. But they're going to be excited, and they're probably going to want to come themselves next time.
I mean, anybody can come and watch the launches. It's super accessible to the public, so we welcome that.
Okay, Barbs, come on down, because this is a lot of fun. I'm excited. Is it about to happen at any minute?
So you see that number right there in the top left corner, 6.5 minutes.
6 minutes left?
Yes.
Oh my gosh, but this is historic. This is a major moment, y'all.
Yeah.
It is.
Is this your first rocket launch that you've seen live?
Yes.
Wow.
Wow.
How do you feel?
Very, very excited. I'm happy it's a good day. I thought it might be like...
I just noticed your shirt. You've got the right swag.
I love this shirt.
It's a great shirt. I have one as well.
And it's a great name, Starship.
I mean, how did you predict the future? Starships are meant to fly.
I do not know. But major shout out to Elon. Elon, thank you for everything that you're doing for humanity.
He's the man, for sure.
Okay.
Well, thank you so much.
All right, I'll see you guys
We want to
later.
watch the launch with you,
Okay, yes.
so we'll take this back because this is too loud to take outside. Wow, what a moment. And with that, great timing. We're now at 5.5 minutes. This brings us into terminal count. Dan, man, the anticipation is certainly growing here in the lobby and out on the lawn. What is it like up there?
Yeah, we are ready to go. We are getting into the final phase of our propellant loading. We are almost entirely full on ship on our main, still doing the header tanks, and we're looking well in excess of 90% on the booster, so we are looking good. Still not tracking any range, any weather issues today, not tracking any technical problems on the vehicle, on the launch pad, looking good for liftoff in just under 5 minutes. Once we're done with propellant loading on the booster, you have over 11.5 million pounds of that liquid methane, liquid oxygen on those 2 stages. After that, we have to essentially get the pad ready for launch. We'll do something called pushbacks, where all of those lines running underground from the propellant farm up to the vehicle, they're going to clear back. They're going to push all that propellant back into kind of the bunker area around the prop farm and just basically get the pad ready. We'll see the vehicles do their final thrust vector control checkouts. So when we snoop in, we should see the engines do kind of final wiggle checks. That's how we steer the rocket. We're going to do those at about T-minus 100 seconds, so a minute 40, and then once we pass the T-minus 40-second gate. If we do need to hold, that is still built in at T-minus 40 seconds. It's built into the countdown. We can pause if we need anything like those pushbacks to complete. If we need anything on the rocket to get ready, we can hold there. We'll only stop if we have an issue. Not currently tracking one. We have one item that might hold us up a little bit just based off of what we've seen in recent static fires, but that's typically only been hanging out for a couple of extra seconds. And then once we pass T-minus 40 seconds, a lot of things will happen in rapid succession.
Yeah, that moment is called the QD, or Quick Disconnect Vent Gate. That's when we clear all the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster configure their comm systems for flight and are rapidly running leak checks on gas and fluid tanks. The booster goes to internal power and its engines get their final priming for launch, while the ship's engines begin their ascent bleed profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly recycle the count under certain conditions back to T-minus 40 seconds and hold there to assess what happened, review the data, and decide if we can proceed again all the way down to T0. We estimate we have around 5 minutes of hold time there. The flame diverter on pad 2 activates at around T-minus 17 seconds, and it enters what is essentially the point of no return at T-minus 10 seconds. And there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes.
All right, we are coming up on 2 minutes. We have completed propellant loading on the booster, just shut down the fuel pump for loading onto the ship, so we're closing all of that out now. 2 minutes to go. One kind of exciting aspect to V3, we're not going to start the engines up in kind of different sets. All 33 of those Raptors going to turn on all at once, and you're going to see the booster move off the pad a whole lot quicker.
Once again, if you've just joined us, this is the first flight for version 3 of Starship. The ship, which is the upper part, the black part there at the top, the booster, which is the part below that, have been completely redesigned, as well as the launch pad that you see it sitting at, as well as the engines that power both the ship and the booster. Today's test flight is a massive step forward in our developmental program.
All right, and we're coming up here on T-minus 1 minute. So let's go to the pad and let the rocket do the talking as V3 fully comes alive.
T-minus 1 minute.
All right, so we did hit the hold at T-minus 40. Again, this is something that is built into the timeline. Not surprising, as we are doing this first flight off of pad 2.
Sounds like we might already be clear. We held for a second just to make sure that the quick disconnect vents were basically ready for their final throwbacks. So we'll hang tight for a couple of seconds. I think we're about to reset, and the reset is in. Counting down, first flight of Starship V3. Psych back to rapid recycle. All right, so hold here for a second. Looks like we're still managing some pressures in the ship quick disconnect. All right, still going to hang out for a couple of seconds here at T-minus 40. Again, not surprising. This is new vehicle, new pad, doing all these things for the very first time. Right now we are holding, looking at some pressures in the quick disconnect, and hold reset, and we're rolling.
Flight directors, go for launch.
Back to rapid recycle, so we're going to hold at T-minus 40 again. Hang tight for a second, we'll see what tripped this last one. As a reminder, we can hang out for quite a few minutes at T-minus 40 if we need the extra time. You're not actively loading propellant onto the vehicle anymore, so the main thing you're kind of keeping an eye on is all of the temperatures inside those propellant tanks. All right, we're continuing to hang out here at T-minus 40. Team's taking a look right now at our diverter, so that water diverter underneath the system did trip a hold, but that basically just gives the team the chance to look at it, see if it's something that we need to troubleshoot in data or if it's something that we can clear this hold. So continuing to hang tight, T-minus 40 seconds. Starship and Super Heavy fully loaded on the pad. Clock is rolling.
T-minus 30, flight directors, go for launch.
Kick back to rapid recycle again. Again, just a reminder, said it before, new pad, new rocket, learning new things about this hardware performing in the flight environment. Taking a look at some of the sensors on the arm that manages the quick disconnect to the ship. I promise we're not just trying to prolong the anticipation. Team's taking a look. We've got a couple more minutes where we can hang out here. Again, it's not an unlimited time to pause at T-minus 40. We're keeping an eye on the propellant temperatures inside the vehicles. So we've got probably about 3 minutes or so left of hold time. Team's taking a look at the hold that tripped on that arm for the quick disconnect on the tower. Continuing to hold. Got a couple minutes to try and clear this issue. Still holding T minus 40, still troubleshooting this issue. Probably got about a minute or a minute and a half left of hold time. Flight control team confirmed, still working through the issue. Still have a short amount of hold time still remaining. Still holding T minus 40. All right, still continuing to hold here at T minus 40. While we do that, the team's looking at temperatures of the propellant inside those tanks. We kind of check that against simulations that we've run in the past. There's some margin in those. We're still holding, no decision yet. Sounding like we have the fix in place. Hold reset, clocks is rolling. And we're back into rapid recycle. All right, we're back at our T minus 40 hold. Standing by to see what tripped us this time. All right, it is sounding like we are not going to be able to clear this issue in time today, so we are going to be standing down from a launch. So if you're just now joining us, we got the vehicle totally loaded. We hit a couple of different holds as we work through that count. Again, new rocket, new pad. We're learning about a lot about these systems as we execute them. for the first time, and we're not able to basically troubleshoot all of these issues in those final seconds to get to launch. But that essentially makes this a wet dress rehearsal. We were able to fully load the vehicles, and we're going to take the time now, figure out what tripped us up before launch, and then actually get into a flight tomorrow. We do have the ability to essentially rapidly recycle. We are expecting to be able to make another flight attempt tomorrow, but obviously stay tuned to our social media at SpaceX on X and our website, spacex.com, for updates. So no flight today. We will give it another try tomorrow.